Okay, cool. So first thing I want to go through is I want to go through connected particles. That's the first thing. Um, one sec. Okay, cool. Mm, so the main thing about connected particles is understanding the interactions between all the different objects in question. So the typical kind of question you can have is, let's say this is a light pan connected to a rope that's moving up with tension T, and it's accelerating at, let's say, zero point 0.5 meters per second squared. And what we have is two objects, um, object A and object B. Let's say object B is on A, and the question could say something like this. Um, okay, it would give the mass as well. So let's call this is 1 kilogram and this is 2 kilograms. Make that better. 1 and 1 kg, 2 kg. Actually, wait, Daniel needs to be here. This is the main thing I need to show him. Let me tell him. One sec. Um, cool, cool, cool. Carry on. Okay, cool. So what we'll say something along the lines of what is the force exerted on A? So force on A by B. So this is the way they word it. And what you have to understand from this is the first thing you should think of here is applying Newton's third law. So the force the force B exerts on A would be the same as the force A exerts on B. Now, when this force that's exerted on B, we call this react. There's a reaction force. If you have to draw the diagram of all these forces, you'd say there's a reaction. And when I say reaction, I mean technically I just mean electrostatic force, so the repulsion of the electrons between the two objects in question. So here we have this object and this object, and they have their own little reaction. We can call them R1 and R1 here. Okay, no, R1 and R2, I guess. Uh, let's call this RA1. No, RB1 and RA1. And then here, no, that's a bit zoomed out, is it? I have to zoom in. But basically, there's two opposite reaction forces that will cancel each other out. They have to be equal. And here we have one um, from the pan or from the ground that's also opposing the reaction force of or the force from A towards the pan. Um, okay, so that's all. These are all four forces, but they are going to cancel out, and so we don't need to consider them when we look at the overall object. And that's the thing about overall objects; things can just simplify. I'll give an example of that with pulleys, but for now, let's answer this question. So the force exerted on A by B. So let's consider just the object B. This object B experiences firstly, let's see, we can draw its weight. So that's going to be 1g. Keep in mind that it's accelerating up at zero point 0.5 meters per second squared, and we also have this. Now we can ignore the force. We're not technically ignoring this force RB1 or RA1, but we're saying that it experiences a reaction force R. Oh yeah, I forgot to answer this guy's question. Sorry. Because we don't. Plus is just the p-value calculated and you should test against significance value p-value of PMCC. The test statistic, yes. Statistic is what we calculate, is the p we calculate, but that's only for regression. Um, that's only for the regression. That's only for the regression hypothesis testing questions, not for all of them. Um, okay, cool. Yeah, carry. Okay, moving on. So yeah. So what I'm trying to say here is that you could draw all these forces, or you could just try to narrow it down. Oh, by the way, this is object B. I should clarify. Okay, you can narrow it down to the object in question and just focus on that. So the first thing here we notice is that the force exerted on A by B is going to be hard to like I guess work with A and a force exerted on A. Um, and I mean I think there is a way we can work it out from A's perspective, but there's just too many. So like we don't know the pan, we don't know the reaction force of the pan, we wouldn't know the force A exerts on the pan, etc. We could calculate tension, maybe work from there because you can think of the pan connected through tension and then you have reaction force, etc. But it's much longer. It's much quicker to just consider B and consider B's weight and the reaction force that B feels, because the reaction force that B feels is due to it exerting a force on A. That's the key thing. Third law, Newton's third law, equal and opposite forces on different on the two objects in question between two objects. If I'm going too fast, let me know so I'll slow down or repeat something, etc. But the reason why I feel I can go fast here is because you can just rewind this. That should be fine. Um, cool. So now that we have a much simpler force diagram, all we're saying now, what the hell, is because it's going up, the resultant force must be up. So doing F equals ma upwards, taking up is positive, r minus g is equal to the mass, which is 1, times acceleration, which is zero point 0.5. So now we have the reaction force is zero point 0.5, which is its mass times acceleration, plus its own weight, which is g. And that makes sense. That you can yeah, you can understand if you're in a lift, yeah. If you're in a lift and you're going upwards, you feel more of a force upon your feet. You can feel your body being pushed into the ground, and as you push into the ground, the lift also pushes back up on you. So that's what happens when you accelerate up. So you can just kind of play with these scenarios in your head, and it should make sense when something's increasing or decreasing. But the typical scenario we do know is when nothing's accelerating, when you're in ground and you're in equilibrium, then you can just say the reaction force is equal to your weight, and that's because there is no resultant. This acceleration is zero, so your r is equal to g, is equal to your weight in this case. The mass was 1, that's why it's g, but it will be equal to your weight in newtons. So that's connected particles. I'm just going to go through a quick time another example with pulleys. So we can have a pulley here, an object there, and let's say an object there, and the ground here, let's say a distance of 1 meter, 2 kilograms, 1 kilogram. So what we have, if we were to draw all these forces, we could say there's a tension pulling this object up. There's a weight down here, which is g. There's a tension pulling this object, or resisting the motion of this object, at least you could say. Here we have 2g. And now what you can do is consider F equals ma along the pulley. There's not a specific direction, but along the line of the pulley. And what we say here is we have, if you consider every force, you have 2g minus t plus t. Because this is going in this direction, this tension is going in the other direction, so they essentially cancel out. So you could consider it, you can just ignore it because you know it will cancel out. Minus g is equal to the total mass of the system, which is 2 kilogram or plus 1 kilogram, 3 times acceleration. So we just have 2g minus g, so g over 3 is equal to the acceleration of this object, and it will be constant acceleration because the question will probably say something like that the rope is inextensible. The modeling assumption you make from inextensible strings is that the acceleration is constant. When something's inextensible, it can't stretch, and when something doesn't stretch, the force along the wire does not change. So that's a bit of physics, but you don't need to know that much in depth. Just that inextensible means constant acceleration throughout, or for the two connected objects. Um, yeah. Just thinking anything else. But once you have the reason why it's trying to work out acceleration is because you can do suvat, work out the time until this block hits the ground, and then plausibly I can imagine a question saying calculate the distance that this object, let's say object A travels after B hits the ground. And in that case, what I would do is I would find out the final velocity of this connected system. So this is a typical question. That's what I'm saying. You can find the velocity of A, different forces in the saucepan mode. The difference. What do you mean? Cool. I'll just draw the diagram again, quick time. Um, Cool. Yeah, yeah, yeah. What was I saying? Yeah, look. So A and B will have the same final velocity at least when B hits the ground. But then from that final velocity, A has no more. Doesn't have this result. Doesn't have this acceleration of g/3 anymore. It just has its own deceleration due to weight. So now A will begin to decelerate, but its velocity is still upwards. So its velocity will start to decrease from a positive value to zero. And the maximum distance it travels is when its velocity becomes zero. So the strategy, the key strategy to, I mean, the main strategy you can use is conservation of energy. So it's kinetic energy at the point when B hits the ground, when A is probably up here now. Its kinetic energy will be zero at a point where the GPE is equal to that KE, and the change in height will be given as is what you're trying to work out x. Um, so that's the way you do that. Now going through the source span thing again, quick time. Um, okay. So first we have this pan. We have an object on this pan. So the fact that this object is on this pan, let's say nothing's moving. Yeah, nothing is moving. So acceleration is zero. No, everything is in equilibrium. This pan is exerting a force down due to its weight. Um, I'm just trying to be accurate. I'm trying. Okay, let's say this is, I don't know, 2 kilograms. This is going to be 2g. A force acting on this object, um, A, acting on this object downwards of 2g. Now this will also feel a reaction force from the pan, which no typically you can draw here, but right now I'm just going to draw this here, on the underside. So this is felt by the object a reaction force. This is coming from the pan, the base of the pan. It's pushing on A. Okay? And I think these are the two forces that would cancel out. I'm just thinking, wait, normally there's something else. I think there's G, and then there's also these two reaction forces. One sec. Yeah. My bad. Okay. So the weight okay. So I thought the third law for the weight was the reaction force, but that's completely incorrect. Um, this weight is just a force due to Earth. That's just going to be there always. It's not one of the. One second. Let me get rid of this arrow. This is always going to be here. This weight of 2g is independent of the reaction forces. It's like a constant 2g weight force, which is weight. But the reaction force is because it comes in contact with this pan. As soon as it comes in contact, it is pushing the object pushes the pan down by a certain force, let's say Ra, and the pan also pushes um, on the object by reaction force Rp, let's say. And in the case where I think this is right, man. I think this is right. In the case where they're not accelerating, Rp is equal to 2g plus R. That's not right. That's not right. It can't be right. Uh, See, this is the thing, man. One sec. Let me look at the note. So Mr. Madoni went through this. So he did make notes on this. I'm just gonna refer to the notes. Yeah. So he's saying that uh they do not feel each other's weight accounted for in the reaction. Okay, contact between objects. Exact, equal, opposite direction. They do not feel each other's weight accounted for in the reaction. Weight is only felt on itself, not by another object. Objects do not feel weight from other objects. Okay, so they only feel a reaction. Okay, so that should be fine then, isn't it? So that's the same diagram I drew. R1, R1, so that's RA, P. Hmm, I guess so. Oops. Yeah, if I'm making a mistake or something, let me know. What's this? Can you do the battery question? Okay, I'll try. The irony of vectors question paper to have exams because what? Okay, cool. Um, my predictions. My predictions for the exam. One sec. Um, I was thinking one thing. Yeah. I was thinking they might ask a. What was it? What was it? A vector. Yeah, a project. Either they're gonna ask. I think they're gonna ask a projectile question using vectors. Either that, or they're gonna ask like a vectors question but using calculus. So the I and J components aren't just gonna be quadratic. They're going or linear. They're gonna be like quartic or cubic, I think. And then you have to do calculus and say at what time is this object moving perpendicular, I mean parallel to northeast, something like that. I think that's potentially could come up. I'm not sure. I haven't really analyzed it, but just have a hunch. Anyways, back to this, man. Back to this. What was I saying? So yeah, so this is so according to Ser's diagram, this is basically what he's saying that the pan feels R1 and the object also feels R1. But I feel like there's a bit more to it that I missed maybe. Um, that's it. Okay, cool, cool. Yeah. So to me this doesn't make sense because there should be something resisting this. Yeah, I haven't completed this. There's a tension here. There is a tension here. Oh, that's fine. Yeah, that's fine. That's fine. There's this tension that would cancel out with this 2. So this R1 does cancel out, and this T equals to this 2G if it's in equilibrium. It's not on ground, it's on the pan. Okay, that's fine. This is correct. So now moving to the second object, B now, we have that, again, this weight, this is just going to be there due to its own weight. Let's say this is 1 kilogram, so this is 1G now. Its weight is not felt by anything else, it's only felt by B. What what A experiences due to B is this type of reaction. Is this electrostatic force, and let's say R2, and because of Newton's third law, B also experiences that same reaction force. So now you can see what I did in this question here. What I considered is I just connected what is B feeling. And when you consider what B feels, this second reaction is out of the picture now. You just have this one weight, so you have this one weight of G, and you have this reaction R. It doesn't matter if it's 2 or 1 because we're completely forgetting everything else, ignoring everything else. And that's the strategy or that's the technique to approach connected particles in this sense. Um, if you can do questions like this, I think there's some in the book. If you can do that, then it should be fine. I don't think you need to know in too much depth or any complicated scenarios. If R1 goes up and down between A and the saucepan, doesn't it just cancel out its own force? Yeah, it does, it does. But I forgot to ignore. Okay, let me just quick time. Yeah, I forgot to ignore. Not ignore. Add T. It will show later on. Okay, cool. What's this? This isn't. It is. It is. It's in the book. It's in the book. Connected particles. Things about light pans and whatnot. Oh, another thing I need to add is the fact that I'm assuming this pan is light. If it's not light, then this will have its own, in fact, weight mg, and the tension will take care of that. I don't have to really worry. It won't affect any of these reaction forces because the reaction forces is due to the interaction between the objects, not the weights. They're completely separate. Um, and finally, another type of connected particles question is when you have objects moving and you have strings connected to them. Or what you might get is the stem giving you information about resistances of each of these objects, but separately. So this is a car, let's say, and this is a trailer being driven by the car, and you'll say the resistance due to the car, all the frictional, or like you'll try to say the resistance due to the car's movement at this velocity is given by this. Let's say R1, R1, and the resistance due to the trailer is R2, and it will say that given that the car is accelerating at oh the car is accelerating at, I don't know, let's say 2 meters per second squared. Find the I don't know, power, no, work done. So you'll ask you something. I should have a question in front of me, but essentially what I'm trying to say here is you can model this as two different objects, each with different tensions. um if you imagine splitting this rope in half and just considering each of these objects separately. Wait, what? Is this further mechanics? Is it not in spec? I swear on it is. Oh, wait. Is the car stuff further mechanics? My bad, my bad, my bad. Is this not here? My bad. You don't do connected particles with cars. I guess you don't. No, no, carry on. Oh, it's not. Yeah, I didn't think it was. Um, yeah. So you can connect. You can consider this one object. Oh yeah. By the way, I set the stream only because you said power. Okay, my bad. Okay, not power. Then work done. Or the force. Okay, let's the force produced by the engine of this car. That fixes it. Um. Oh yeah, by the way, I fixed the stream. I made the stream setting so that the latency is less, so that we can interact a bit quicker, and there's not that much of a delay between the stream and yeah. Yo, I told you we do. Yeah, because but the saucepan isn't. Yeah, the saucepan isn't further, bro. Work done. My bad. Yeah, we don't need to know work done, AJ. It's in year two book. Um, cool. As I was saying, we can consider these two objects moving as separate objects. So now we consider that this trailer is being driven, is being pulled along by this rope with with the force of T, and its resistance is R2. So now we have, and this acceleration applies to this trailer because of the fact that the light, again, somewhere in the stem should say the rope or the rod connecting them is inextensible, or it's like a light rod. Things like, if it says rod, that also means inextensible because we assume rods to be inextensible. Um, yeah, so this has a force T and another force R2, or just the resistance that is given. I mainly understand it now. Yeah, if you have any little things, text me when you start. Okay, cool, that's calm. Um, so yeah, now you can do a force diagram with this one object too to find the tension. Equally, yeah, not equally, but you need to find tension here from the second object. Why? Because this is additional force on the car which we don't know, which is F. And if you try doing this separate object thing on the car, ignoring the trailer, you do not have enough information to work out F because you have an unknown T. So the point of this is to work out T. You don't you work out T, or you set up an equation in terms of T and R, either one of those. Um, right now we can work out T because the information, let's say, gave to R2 is equal to this and R1 is equal to this. From here we can say T minus R is equal to the mass of this, let's say 250 kilograms, sounds about right. This is, I don't know, 1,000. Hopefully that's right. Yeah, T minus R is equal to 250. Acceleration, which is 2. So that gives you 500, and the tension is going to be equal to 500 times the 500 plus the resistance, this resistance, in newtons. Once you get that tension, that it eliminates the unknown from this car. You can work with the car saying this is F, this is tension, which we know, and this is also the resistance. There's another resistance. You can put them together, but in your diagram at least put them separate. Work with the car now. So F minus T minus R, doing F equals ma this direction. Taking this as positive, this direction as positive. F minus T minus R would be equal to the mass times acceleration, which we know we're given to be is 2. And from here we can work out F. Probably 5 marks. This type of question. If there anyone else has a type of connected particles question, let me know. I'm just gonna move on. Other than that, I think that should be fine. Okay, I think I was gonna go through stats next. I don't know what's on the agenda. Don't you assume the car and the trailer as one object? Yes, you could do that. Yeah, that should be fine. That would be fine. Um, but okay, yeah. Let me think about this before I waffle. Um, I think there's a specific case when you can't just treat them as one, and I think that's when you have missing information. I'm trying to think what it was. Not too sure. Uh, okay, so what he means by connecting the objects is this. So someone help me out, well, by the example in which you have to split it. But if you don't want to split it, you can do this. You can treat the trailer and the car as one object, as you know the tensions would cancel out, and say that the combined mass is now 1,250. The force forward is still F, but now the force backwards, or the resistances, is now R1 plus R2. Now that you have these combined forces, you can set up your diagram here with acceleration being 2 meters per second still, 1,250 times 2, and this F would equal this F. Um, keep because you can check that quick time because you can see this is 2000, this is 2500, so the difference is 500. This R is R1, so that's the same, and this the difference is basically this is minus T and this is minus R2, but we know T is 500 plus R2, so it makes up the difference and the forces are equal. But so you're right, you can completely do this way, but there's a specific case. Oh yeah, when you ask to find tension. Yeah, when you ask to find tension, there's no other way to do it. If you connect objects, the tension goes. Can I rotate that? I don't know how to rotate. Oh crap, that's mad. That's big. I don't know how to rotate. Damn it. This? No, no. Rotate, rotate picture. Hey, come on. What's this? A truck. Okay, inextensible. Check. Light. Check. Smooth pulley. That means there's no frictional forces due to the pulley. Produces driving force D, slowed by constant, that's F500, that should be annotated then. Resistance force of F500. Creech, okay, so 3 meters per second after 5 seconds, so you can do suvat to find what the acceleration should be. You know the initial velocity would be 0. Um, when the crate reaches 3, the rope snaps. Given that the driving force remains the same, what's this truck's new acceleration? Okay, this is a pretty long question, so you guys can have a go at this. I'm gonna. I don't think I have enough time to do too many questions today. Um, but this is very similar to this example here. Which one? Where is it gone? This one. One second. Let me slide across. This one. So you have two connected objects, but except this one, the what do you call it? This resistance, the resistance of this, you could imagine this being the trailer, is not only due to the friction with the surface, but its resistance is now due to its own weight. So its weight you can imagine is the resistance. So when you do F equals ma, you do F equals ma along this direction, taking this one as positive because you know it's moving that way. Um, you solve that to work out A. Once you work out A, you can then treat this as one connected object with the combined masses with D and 250g being the forces to work out. So D minus 250g is equal to 4,250 4,250 over 9.8. No, that's 4,250 times the acceleration you work out A. Work out D from there. When the rope snaps, this force D remains the same. Oh wait, I can't forget 500 minus 250 minus 500 is equal to that. When the rope snaps, the only force now is D and 500, so D minus 500 is equal to 4,000 A. Work out A from there. Uh, how much time elapses between the moment when the rope snaps and when the crate hits the ground? When the rope snaps and the crate hits the ground. Okay, that's just projectile motion, I guess, or you could do that for this object. Keep in mind that it still has an initial velocity of initial velocity of, let's say, um, positive or minus 3. No, let's say, let me think about this. It'll be, if you take acceleration down as positive, so that's g, this would be minus 3, and this would be, we don't care. We don't know. We don't care about the final velocity. We just want to know the time. Initial velocity is minus 3. Acceleration is g. Distance it travels. Do we know the distance? Uh, we want to know time. SUVAT. Given, yeah, this is at rest on the ground. So from this suvat, you can work out how far it went up and work it from there. So you can get distance from here, from this part. Okay, cool. Possible improvement that could be made to this model. Don't assume the rod to be or the rope to be inextensible, because it will probably stretch in certain places, making the acceleration different for the objects. That should be enough. Cool. Rule of mechanics is common. I feel that more so than common sense is a bit of intuition. Like when you have to be able to feel the objects in a sense. Like if especially with the lifts one or moving objects or with cars or with forces, you need to feel in a way those forces. And if you can feel them forces, I think you have like a direction with the question. You know what you should get, so you know what to work towards. If that makes sense. Cool. What the hell, man? Don't troll me again, bro. Tuesdays, you have a gin if you feel the forces. Ah, man. Uh, I wanted to go through something, but I forgot. Yeah, okay, cool. So this is hypothesis testing with normal distribution. Okay, going through on Steam. What's the time? Well, time mark is flipping 30 minutes. Okay, so hypothesis testing with normal distribution, I think is probably. I mean, I think it might. It could potentially. It could be the hardest. Actually, no, I take that back. The binomial expansion potentially could be the hardest, depending on the wording of the initial question. But the only reason why I say this could be hard is because it's the last topic we done. Was already watching. Oh, okay, nice. Diameter d normal distribution mean that it's in centimeters, so I'm going to just ignore units from now on. So I'm going to say D is now normally distributed, um, is distributed using normal distribution, whatever you call it. 0.58 square root, oh wait, standard deviation squared in it, so 0.15. 0.015. Yep, that's fine. The machine is serviced, and after the service, a random sample of n equals 50. For the next prediction, mean diameter. So mean diameter. Okay. So this is very important. This means you can't just use this. You have to now work out the sample mean, and that is given by this. The mean stays the same, the sample mean, but your variance is now going to be. Uh, so, so we know that the I think this should be squared in it. Standard deviation squared. My bad. My bad. Standard deviation squared. 0.015. Yeah. 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 And now this would be 0.015 over n squared. Wait. What was the formula? No, it was this. 0.015 squared over n. See, this is the problem. I'm not sure if it's in the formula book. Do you know? No. Let me check. Let me check. Let me check. Quick time. I'll check. 56. Yeah, it's sigma squared over n. Calm. This is 0.015 squared over n. See, you have to make sure you remember these things then. To see if it's been changed from 0.58. The distribution of the diameters after the service is still normal with a standard deviation of 0.015, which is the same there. Find 1% level critical region for this test. Um, because we want to see if it's changed, it's a two-tailed test, so this is not equal to. Mean diameter is calculated to be, that's the test statistic. Comment on this observation in light of the critical region. Okay, so they're directing you to do it a specific way. This way they're trying to get you to do it is by, you can use either inverse normal or you can use standard normal distribution. But the goal is to work out the critical region first, so let's crack on with that. So what we're saying, this is a two-tailed test with H naught is P, not P, but the sample mean is equal to, what is this, 0.85, 0.58. And that alternative hypothesis is that the sample mean is not 0.58. In essence, we have a two-tailed test. Significance needs to be halved. Keep that in mind. Half uh, is calculated to be okay. Yeah, that's fine. So now get your bust out your calculator, and what we're trying to do is work out the value of d such that this area is 0.05 a 0.0005005, and the value for which this area is 0.0005005. Um, there's two ways again. So okay, I'm gonna highlight both. I think the inverse normal is the quicker. You don't have to worry about the standard normal. So inverse normal, bust out your calculator. Go to menu, go to 7, 7, yes, 7, and inverse normal 3. We know the area is 0.05 because the area is equal to probability. Now, the mean, oh, sorry, what do you call this? Standard deviation? Yeah, standard deviation, remember, is going to be the square root of this variance. So 0.015 over n, square root n, which because that's the square root of this, is our standard deviation. Okay? So what I'm trying to say, originally our standard deviation was 0.015. Our variance was 0.015 squared. Our new variance is equal to, in the formula that is, mu is that. This is our new formula. Therefore, our new standard deviation is the square root of sigma of, sigma squared over n, which is sigma over square root n. Hope that makes sense. So plugging that in, so we have 0.015 divided by square root of 50. I have 2.1 times 10 to minus 3. The mean is still 0.58, and that gives us this value, this value, the critical value, that d has to be less than 0.5765. And for here, I'm going to say my area is 0.9. Oh wait, my bad, my bad. I plugged in 0.005, and that gives me this to be. This gives me 0.5745. Okay, and this one is when I put 0.995, I think. Yeah, and that gives me d has to be greater than 0.58546. I think hopefully everyone's following, man. It's not in the formula book. Why did SD change? Okay, cool. I'll let you. First thing, it's not in the formula book. Okay, cool. So I'm gonna write this out to make sure everyone gets this. Then it's not in the formula book. So that means okay. So first, let me start off by why I had to use a formula, because this question was referring to the mean diameter for a sample n, in this case 50. So for a sample of 50, when you want to find the mean of something, the the normal distribution of that variable changes. If you just take one, what do you call it, one unit from the assembly line, when you take one unit, the normal distribution for that one unit is followed by the one we all know, the one we're familiar with. But when you take multiple and then do an average, you can think about in terms of the, okay, let me try to explain this in great inaccuracy, in good accuracy. This is a normal distribution. This is a normal distribution. We have a certain mean, and then we have certain values of, diameters in this case, where it's extreme. Certain units will have low diameters, certain units will have high diameters, and this can be modeled by a normal by a normal distribution with a mean and a certain, variance, where the variance tells you the spread of this data. If something is more spread out, it will look like this, and if something is less spread out, it will look like this. Now you can imagine if you take multiple, what's the object here? Multiple bolts. So this is for one bolt. This is for one bolt. If you take 2 bolts, 3 bolts, 5 bolts, 10 bolts, yeah. If you take multiple bolts, let's say 100, you take all of them and you do the mean of them. Then what you have, what you end up getting is the mean for random samples of 100 bolts approaches the mean of any bolt. The values, or this, spread gets narrower and narrower and narrower as n increases, and eventually what you get is the variance is very small, and that would make sense because when you take average of something, the, what do you call it, the uncertainty, or oh, shut the hell up, man. um, you troll, you troll. The uncertainty, or the, what do you call it, the anomalies decrease in that sense. They get averaged out. So that's why you have a different formula. Okay. Do you need to remember that? No. Is that important for the exam? Probably not. So why did I say it? Just so that you have an understanding of where the formula comes from. So then you can understand why the variance decreases. Anyways, so this is for one specific bolt. Mu sigma squared. But when you take a mean of n bolts, it becomes mu sigma squared over n. And that's the reason for that is what I just said. Hopefully it makes sense. If it doesn't, I'll repeat it. Show that message to your family. Bro, he's I don't okay. Can you do my question, please? Yeah, I'll do it next. I'll do it next. You see, listen, I'm forgetting what I told people to do, so I'll come back to that. Thank you, boss. Reject null. Oh yes, yes, yes. And you finish this question as well. um, fine. So this is my critical region. My hypothesis has been stated clearly. Now, finally, comment on this observation. That's basically saying, looking at this test statistic, is it in my critical region? 0.587. 0.587. Yes, it's too big. So anything bigger than 0.585 is too big. It's in the critical region. That means that I need to reject my null hypothesis. So there is sufficient evidence. So again, I'm going to write this wording out. Sufficient evidence to reject. Oh, by the way, because you guys are on mobile or whatever platform you're on, hopefully you can read my writing. If you want me to write it bigger or make the images bigger or anything, let me know because I'm on a computer, so it's different. Isn't it? Sufficient evidence to reject H naught. Um, there is enough evidence to suggest that the mean. So point one, accept or reject H naught, H null, H whatever. And second point is in context. You have to bring the comment um, observation in context. So there is enough evidence to suggest that the mean bolt diameter has changed. That's it. We don't need to say more or less. Just say it's changed. Good enough. That should be the full marks for this question. Now, before I go into Ishak's question, actually, what was Ishak's question? Maybe we'll answer. Nice one, bro. Ishak. Is this a distribution question? Okay, cool. So this is a distribution question as well. What's this? Part C. Large data set. Large data set. I'll quickly go through what I think you need to know. If there's anything missing, let me know so I can learn as well. Calculate the daily mean. What's this? Calculate the mean of the daily mean temperatures of the daily. Flip sake. Calculate the mean of the mean daily temperatures. Okay, that's fine. In 2015, the standard deviation was 1.05, 1.02. Compare the mean daily temperatures in the 2 years. 2015. Oh, oh, see. Why is it zoomed in? What the hell, man? I reckon what you have to do is work out the mean from this information. Yeah? Yeah, you do. And then you compare the mean. And the policy, a recorded temperature is considered normal for the time of year if it is within one standard deviation of the mean. Estimate for how many days in September 2015 a normal mean daily temperature was recorded. State one assumption you have made in making the estimate. So, September. Okay, bro, if you can send me your question, you're working out for this question, like part A and part B, I might need it for part C. I think I need to know the mean at least, I think, to be able to do this part. So if you can send me your working for there through WhatsApp, I'll do that. But for now, let me do this question fully. The random variable x is normally distributed with mean and variance. Okay, distribution x of the sample mean x. So let me copy this. Is this the stats page, isn't it? Yeah, the stats page. Stats page. Thank you. Chem English. Yeah, cool. Yeah, EZ. So about that, so I think what you need to in terms of that, you need to know the kind of trends certain areas would have. So obviously, I think we all know that we need to know certain locations, but you also need to understand what type of weather those locations would have. Specifically, as when they're close to the equator, it's going to be hotter. When you're close to the equator, you have lower pressure. I think when you're further away from the hemispheres, I think you have higher pressure. I think I'm just speaking from geography knowledge. I'm not sure if that's correct. Someone's gonna have to confirm. Um, Going back to this question. First of all, we have x distributed with mean sigma squared. Now x bar is going to be distributed with mean and sigma squared over n. Construction company wishes to determine the mean time taken to drill a fixed number of holes, determine how large it is so that the expert can be 95% certain. That's interesting wording. That the sample mean will differ from the will differ from the true mean time by less than 15 seconds. Assume it is known from previous studies that mu is standard deviation of 40 seconds. Damn. Determine how large a random sample is needed so that this expert can be 95% certain that the sample mean time will differ from the true mean time by less than 15 seconds. I'm trying to understand this myself. I don't know how to do this straight away. One sec. I'm trying to understand this sentence first. Sample mean time will differ from the true mean time by less than 15 seconds. So okay, I think it's trying to say this minus this is less than 15. So the sample mean subtract from the true mean. Oh, is this, the true mean is just mu in it? Yeah, yeah, yeah. Is less than 15. Assume that it's known. Okay, so that's all we have. And 95% certain. I don't know. Um. uh, okay. So this is only going to be true. Okay, cool, cool, cool. So now I'm gonna draw the graph of the sample mean. Cool. I'll get to that. I'll get to that. So what I want. No, I don't have to worry about this. I can just imagine the mean being this origin line, and this is going to be plus or minus 15, and I need it to be so that this area is 0.95. Cool, cool, cool. Correct. That makes sense now. Let me just draw it bigger. So this area, I need to find. I need to find. What's this? I don't know what I need to find. This is plus minus 15. No, no, no. Yeah, it is. It is. It is. One sec. I'm trying to understand this myself. So this is time. Um, X bar. This is the mean, and this is mean plus 15, and this is mean minus 15. Okay. Okay. This area needs to be 0.95, and this is all we have to work with. That mu is 40. Mu is 40. So let's work. Let's do stuff. Let's do stuff. One sec. Um. Okay. If that's 0.95, we know that this must be half of that. So what do we have? Mu. Okay, we know the standard normal. The standard normal to get to that. Mu plus 15 minus mu over distribution is equal to z value. And we okay, yeah, that's fine. That's good. This is right. Okay, okay, cool. Okay, so for a specific data point, minus its mean over its standard deviation will give you the z value for that point. And where the z value is the standard normal. And as the standard normal, we can always work out using inverse normal the inverse normal or the table. I'm going to use inverse normal because I don't want to look up tables and stuff. What am I going to look up? I'm going to look up the value of the z value such that this area is 0.95 divided by 2, 0.5 minus that. Why? This is zero point 0.5. This area is 0.5. This area is 0.95 divided by 2. So zero point 0.5 minus 0.95 over 2 will give me this area. I think this is a hard question. Unless this is simpler than I'm doing. But yeah, this will give me a z value. This will give me. This should be negative, isn't it? One sec. Zero point 0.5. No, this is a positive area. So this is some probability. Probability. I'll put this into my inverse calculator, my inverse normal, and it will give me some value. So let me do that. Let me do that. Inverse normal area is 0.5 minus 0.95 over 2. That's 0.025. The mean, the standard deviation is 1. The mean is 0. That gives me z is equal to minus 1 point. Ah, is it? 90, yo, you're right, you're right. You are right. So there is a quicker way to do this. Oh, yeah, yeah, yeah. I don't know what you're on about. Oh, you're not. Oh, you're talking about something else. Okay, so that means that keeping that in mind, that 95% mean is two standard deviations. That means the mean plus 15 is two standard deviations greater than the mean. So mean plus 15 minus the mean. Thank you. So this is two standard deviations. Um, so this is 2 sigma over square root n. Oh, oh, that's it. That's why it's only 4 marks. None of this working out is necessary. Okay, let me explain this question again then, with the information. Thank you, Manvir. This method would have worked, but as you can see, it was very long. um, what do we need? We just need this information. Anything within two standard deviations of the mean will sum together to give you 0.95%. I mean 0.95, 95%. So that means that any one side would have to be two standard deviations away from the mean. So 15, if we just ignore the mean, is equal to two standard deviations. But remember that the variance of this new sample mean is sigma squared over n. So the square root of this, the standard deviation of this, will be sigma over square root n. So now we just have square root n is equal to 2 sigma over 15. N is equal to 2 sigma squared over 15 squared, and where sigma is 40. Good, nice one, man. Yeah, that's n. Let me know if that makes sense. Ish, I think that should be fine. Cool, I'll do that now. Yeah, yeah, safe. Okay, this. Uh, yeah, yeah, yeah. Let's get your Can you send me a link in the chat? It will be much easier for me to get through there. Uh, They're working out. Yeah, exactly. So what I was doing basically was essentially deriving that result where the two standard deviations within the mean is 95%. I was just working it out like from the beginning, from scratch. I think in the end you would have got the same answer, but obviously one way was much quicker than the other. No, what was I trying to do? Yeah, your question, your question, your question. Mean was, you said, 11.9 and 12.1. So this is um, X bar 1987, 2015. Okay, cool. So now I have that normal one standard deviation of the mean 2015 is 1.02. Um, so 12.1 plus 1.02 plus minus. I think what I'm probably going to end up doing is distribute this using a normal distribution. So I'm going to say minimum and maximum is that. Median is this. Mean is this. Actually, I need to work with the mean. Sum of x squared. That what information helps you work out the mean in this case. Um, so yes. Actually, no, no, no. We can just use Manvir's method again. Within one standard deviation, is I think 68%. 68%. Let me just use my inverse calculator to work it out quick time. Area, not inverse normal. I'm gonna say menu 7, normal cumulative 68. Okay, 68%. 68% of the days. So assuming that the data is distributed using a normal distribution, um, the number of days will be 68% of the number of days in September. So what? January, February, March, April, May, June, July, August, September. 30 days. So 68% of 30 for 3 months. That's not enough. That should be enough work. Using this to get that, and then using your knowledge of SD to get that to make this conclusion should be 3 marks. Maths made easy. Thank you for that. Okay. Well, is this 2018 paper? Yeah. Oh, good. What did you go through this, anyways? Um, I heard it was very hard. I heard it was like a conditional probability normal question, so I won't be surprised if I can't do it. Okay. Uh, I'll try. Obviously, I'll try. Do you know what question it was? There we go. Chalo. Go try my best. Okay, the lifetime hours of a battery, normal distribution. Quick time, write this down. Mean 18, standard deviation 4, so that's 18 full squared. This calculator requires 4 batteries and will stop working when any one battery reaches the end of its lifetime. Okay, find the probability that a randomly selected battery will last for longer than 16 hours. That's that you can just use that into your what do we call it? Use your calculator. Lower end 16, upper end 10 to the 6. Why the hell not? Let's see what I get. Quick time. Lower end 16, upper end 10 to the 6. Um, what's this? The standard deviation? What's this sigma again? Yeah, yeah, yeah. The mean is 18.69. P is equal to. Answer to previous question was 15.9. Which was this one? Or this one? Um, so so you're saying that's not right? 0.68 times 20.4. Oh, do you have the working out for that? Send me that and I'll have a look. Because looking at this again, I think it would be 68% of 30. This one. Oh, what did I say it was? Um, critical temperature. Okay. What's this? What's this 14.1 minus 10.1? 14.1 minus 10.1. Oh, is this like some sort of interpolation? Yeah, 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 they're interpolating. My bad. My bad. My bad, my bad. So I assumed it was normal distribution because they said the word normal. What they're doing, in fact, is just interpolation for the entire duration of the month. So if you imagine a month as a class interval, as a class width with 0 to 30, um, and a minimum of 10.1 and a maximum of 14.1, and assuming all 30 days are evenly spread out, they're interpolating. So that's just interpolation. My bad. I would not got those 3 marks if it was an exam. Anyway, I want to do this battery question. I wanna, yeah, see what I get. Lower 16, upper 1 10 to the 6, 418, 0.69, 1 4, I guess. 146. Okay, 1 5. This time I have my calculator. I'm not messing about. At the start of exams, Alice puts 4 new batteries in the calculator. She has used the calculator for 16 hours, but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working for Alice's remaining exams. Okay. Um, it's 5 marks, so it can't be short. This is a probability that a calculator would last for longer than 16 hours. And this is a randomly selected battery. So, what I'm thinking of doing is finding the probability that a randomly selected battery will last for more than 20 hours. Find and using that okay, yeah, so this is my method. I'm doing now same method, but my lower will be 20 and my upper is the same thing. Let me find this probability now. This is equal to 0.3085. So let's just say 0.31. Now I'm going to do a binomial distribution for the batteries, saying batteries 20 plus hours is going to be distributed by the binomial distribution NP, no, what was it, NP, yeah, 4P, 0.31. I want to know the probability that L is uh, equal to 4. No, what was it? Yeah, L is equal to 4. I need all 4 batteries to be these batteries. So that's just 0.31 to the 4. I don't know if that's 5 marks. That doesn't seem enough. Maybe I'm missing something. She has used a calculator for 16, has another 4 hours to sit. So basically, she wants her calculator to work for 20 hours. So a battery, the probability that any random battery works for 20 hours, using the normal distribution gives me this probability. If I use a binomial distribution with 4 batteries, with that probability, and saying that all 4 need to last for that long, this is the success to the power 4. I think that works. I had to take it down. The paper one walkthrough, my teacher gave me an email saying that the Edexcel papers are meant to be secure for 6 months at least, so I just took it down. Part B is conditional. Flip sake. I knew I was missing something. Find the probability that calculator will not stop working for Alice's remaining exams. Oh yeah, it's given. It's given that it's already used for 16. Ah, flip sake. Find the probability that calculator will not stop working for Alice's remaining exams. So given that it survived for 16 hours, find the probability that it survives for another 4 hours. Um. Okay, so now I'm thinking this. Okay, yeah, I'm thinking this. From part A, we know that the probability a battery survives for 16 hours is this. Now my working out to work out for battery. So okay, a battery can survive 16 hours or cannot survive 16 hours. Yeah, it dies. And if it survives 16 hours, it can also survive another 4 hours or it cannot. I don't care about here. I don't really care there. What I care about is the probability that it selects it survives 16 hours and it survives another 4 hours. Okay? Um, so this is a probability. I'm just trying to explain this correctly. This is 0.6915. I know that. Yeah? I know that the probability, let's say this is x. I know that the probability a battery survives 16 and 4 hours, 20, is equal to 0.31. So 0.6915 times x is equal to 0.31. Therefore, x is equal to 0.31 over 0.6915. Why? Because this expression x I wrote is the probability that b happens given a. So x is also same as saying b given a. Safe man, man. Um, be given a, and that's what I want to work out because given that they survive for 16 hours, that's such an important part. Where to go? Find the probability that it can survive that much. Now I'm going to use this probability here. Let me just quickly work this out. That is 0.31 over 0.6915. I shouldn't have rounded, but oh well, I rounded already. 0.4483. Now I'm going to say this here is 0.4483 to power 4. This should be my final answer. That's enough work for 5 marks. Now I don't feel like I'm missing something. I need to divide the two numbers. Yes, thank you. uh, hopefully there's not too much of a delay for you, man. What's this? Maxim. Okay, cool. Thanks, man. Thanks. I should probably show your other comment as well. I don't know why I've hidden it. Well, my bad. Sure. Cool. Alice only has two new batteries, so after the first 16 hours of the exam, although her calculator is still working, she randomly selects two of the batteries from calculator and replaces these with the two new batteries. This is getting complicated. So the probability that calculator will not stop working for the remainder of the exams is 0.1993 significant figures. Damn. So after the first 16 hours, although her calculator is still working, she randomly selects two of the batteries. So that's a completely new battery, and I only have to find so this only has to last 4 hours. The two new batteries. So now this is um because she's removing two randomly. What happens to my probability? Let me see. Where's my working out? Okay. So two 16-hour batteries I have, and two new ones. The batteries she removed has been removed randomly. So now, and it's a show that, so at least I can check my answer. Thank you for that, Excel. Um, so now okay, in my head, I'm thinking these two new batteries are very unlikely to be the reason why they die, but I'm still gonna have to incorporate that into my final probability. The main thing is making sure that these guys are the ones that survive. So, I think I can just say the probability that these two survive is 4483 squared because each of those I'm going to assume are independent, and yeah, this is going to be 4483 squared. The probability that these two survive, and the probability that the two new ones survive, is going to be using my normal distribution, L, the L is distributed in n 18 4 squared, the probability that they survive for 4 or more, so the lower bound is 4, upper bound is 10 to the 6 again, just for sake of the calculator, and work out the probability of that. That should be a pretty large probability, I think. 4, 10 to the 6, was the standard 4, I think, and this was 18. Was it 418? Yeah, 418. 0.999. Yeah. So again, so this is not really affecting it. 0.9997. So that's just basically one. So now is 0.4483 squared what I'm looking for? No, it's not. Or if I do 0.4483 squared times 0.9997, maybe that would work. Let me see. 0.4483 squared times 0.9997. No. Maybe I shouldn't have rounded. Let me see. Anyone have anything to say? Or should I just look at the mark scheme? Uh, but if a question like this comes up, I'm expecting people to complain again because this is pretty gnarly, dude. What question is this? 5. I don't want to look at too much. I just want to see because this is very close. I'm missing slightly something. I don't know what. 5. I have that. I have 0.44. That's Did I say 0.448? Oh, I've rounded it so much, so obviously it's gonna be bloody wrong. It's gonna. I have to make sure I don't round my answers, man. So that's 0.44621 squared, and that's 0.199. Okay, so that's fine. That's fine. Let me finish the rest of it. Want some good stats resources? Yeah, safe, you're right. Last year's paper. I'm doing the hard question. The hard question stream. Bro, listen. If you think your mate done it, I done it as well, man. I walked out of the exam thinking, why is there no trapezium rule, okay? And then my mate's like, oh yeah, how did you get the trapezium rule question? I'm like, flip's sake. I thought it was a mechanics question. I was surprised it was in there, man. I done, like, I didn't even do, oh man, I made my own rule up. I done speed is, yeah, distance over time and distance speed times time for all the intervals. And I worked out the distance for each of the intervals and added it up. I got something like 350 meters, man. Flip's sake. Gnarly, yeah. Uh, I messed up on that, man. But it's fine. I'm not. You can't let previous exams bother you so much for next ones. You just gotta chin up and move on, man. This is wrong. This is 0.4462 or something like that. Yeah. Anyways, what's the next part of the question? Show, yeah. After exams, this is 5 marks. Chunky. Alice believed that the lifetime of the batteries was more than 18 hours. She took a random sample of 20 of these batteries and found that the mean lifetime was 19.2. State your hypothesis. Okay, this is not bad. She believed that her lifetime was more than 18. She believed that the lifetime of the batteries was more than 18. She took a random sample of 20 and found that their mean lifetime was 19.2. So yes, fine. So she believes that L. So H null is L is. Oh crap! How does that work? Can I say L is greater than 18, or can I say it's equal to 18? Um. Oh, 18. Yeah. Sorry, my bad. L is equal to 18 because we're given that the mean is 18. So she believes it's greater than 18, but that doesn't mean it is. What the hell? Waste, man. H1 is that L is greater than 18. One-tailed test. We have sample mean is distributed normally with the mean being 18 as assumption. This is going to be 4 squared over 50 in it. She took, I mean, battery's 10, 50, 20. I don't know why I can't remember things like that. 20. Mean lifetime was 19.2. Stating a hypothesis clearly using 5% level of significance. Test Alice's belief. 19.2. What's the probability of L being greater than 19.2? Uh, um, well, hang on a second. What's the thing where you go from normal distribution to binomial distribution? Like something about continuity correction. I'm gonna need to go through the book for that. I forgot. It just popped in my head. But anyways, L is greater than 19.2. What's the probability? If that is less than 0.005, 0.05, 0.05, then we reject it. So what's this probability? Calculate 7 normal distribution. Lower is 19.2, upper is 10 to the 6. We want the extreme. This is the square root of 4. So that's the square root of 16 over 20. The standard deviation, that is. The mean is 18. And this gives us a probability. Sorry. 1 minus the probability L being less than. Wait, what? Oh, wait, what? 1 second. 19.2. Yeah, what? That doesn't make sense. 19.2 and greater than should be a less than zero point 0.5. Oh, this is 0.0. My bad. My bad. I misread my calculator. 0.08985. That is greater than 0.05, so not enough evidence to reject H naught. And you say the usual that the mean of the battery is likely to not is still be 18. So let me check the mark scheme. Yeah, insufficient evidence 0.8985. Yeah. Calm. 4 over root 20. Yeah. Nice. Cool, cool. So I probably would have got this part wrong, and because I got that part wrong, I probably would have got this wrong. Yeah, but this part would have got, I think. So that's 8 marks, man. When something's chunky, don't think it's simple. When something is 5 marks, this 5 marks worth of work at least. Take that, take away message for me. Crush. And then had paper two, but probably gonna do paper two. The integral with the rectangles funny. The rectangles you need just to throw you off. The next two is dirty, giving us only 2 hours and ran out of time. The last question was horrid though, and the vectors one. Oh yeah, I don't know. It's only 6 marks total. The vectors question, I think they were trying to not to. I don't know, man. I don't know why it was only 6 marks, but obviously people that didn't get it are going to be happy that it was only 6 marks. The integral question, I've said this before in my previous stream as well. There's this guy called 3 Blue 1 Brown. He goes through the essence of maths in that sense. So he went through the essence of calculus, and the integral, the way he taught the integral, the way he showed the integral was direct. It was exactly that. It was the first. It was through first principles, I guess you could say, where the sigma x approaches zero. Uh, uh, Joker. What else is there, man? Bro, I'm just a flipping. I'm just a pebble in the ocean side. What else is there? Uh, Daniel sent me questions. Oh yeah, well I said I wanted to go through something in it. Let's do that. Let's do that. You need to remember me, man. Keeps on forgetting. Is it year one, year two, year two? Do I have any tips? Um, uh, I can't really think of them at all. I made inverse normal, standard normal, approximating a binomial. Yeah, approximating. Oh, that's approximated binomial. My bad. I thought it was normal to binomial. Yeah, yeah, yeah. This stuff. NP, NP1 minus P. They would normally, I think they would tell you to do normal. Normally tell you to do normal. Anyways, continuity correction is the key thing from to learn from this. Is that because binomial distribution can only take discrete values, when you do normal, instead of doing p of x greater than 5, you have to do it group p x greater than 5.5. Huh? Uh, I would have thought it would be 4.5. Oh no, because we don't want 5. Yeah, yeah, yeah. Let me draw this in a number line. So if you have chunks and this is 5, if you want to know the probability p of something being greater than 5, we don't want to include 5, and a normal for the normal distribution, you have to go in the decimal places, so it's going to be p of y greater than 5.5, because it can't be. Yeah, basically, yeah. I don't know how better to say that. Ooh. Rough beam, mass 14, length 15, 14, 15, 13. Is that triangle? I'm not sure. Rest of the A on rough horizontal ground. Beam is supported by a smooth peg at C, AC, so it makes an angle. The point of slipping. Find the coefficient. It's uniform. That's nice. 7.5 meters away, then that means. It's supported by a smooth peg at C, angle of 18. So there's a reaction force there. Oh no, no, hang on a second. Um, the beam is supported by a smooth peg, AC. It makes an angle of 18. The beam is on the point of slipping. Find the coefficient of friction between the green. Okay, so there is a mu r there. Surely there's a reaction force there as well, I think. Uh, but maybe you can ignore it. But if you take moments about there, we can just ignore that. But then there's a reaction force as well. Ugh. What was the way to do this question? Beam is supported by a smooth peg at C. AC is 13. It makes an angle of 18. Beam was on the point of slipping. Um, Parallel and perpendicular to this, I think. Ah, yeah. But there's a reaction force here. Yes. Uh, is going to be in terms of the reaction force? No. Yo, what am I missing? Sean? Um, I guess so. Yo, I'm not sure how to do this. Let me think. I mean, let me know if you have a way. I can resolve the forces. I know how to resolve the forces perpendicular and parallel to this beam. I'm thinking of either doing moments about here. Yeah, I should do moments about there. So I can work out this force. And this force is reaction force. And it will be perpendicular there. Okay, yeah, let me do that. So moments about A, taking that as positive. I have this force as going to be 7.5 times 14g times cos of 18. I'm going to think about the distance. This is cos of 18. Is equal to reaction of C times 13. Does that work? Yeah, I think that's fine. Quick time. 7.5 times 14 times 9.81, no, 9.8 because it's in physics. 9.8 times cos of 18 in degrees divided by 13. So RC is 75.2798. Okay. Oof. I'm not gonna memorize that. You dumb. Oh, flip that. Average, minimum, maximum. Okay. What else the average? Quick time. Look at that. Yeah. I don't wanna. Will be familiar. I don't know how long I'm gonna go for, but I'm gonna at least finish this question. Um. Okay. So now my diagram looks like this. I have this. I have this force. I have this force. I have this force and that force. This is A. And now that I have this force, I have this force. I am going to do F equals ma. Yeah, sure. Why not? Yeah, yeah. No. That's not enough. That would not be enough to work out mu and r. Um. Yeah, I can. Yeah, I can. I can resolve the resist. Yeah, I can do F equals ma vertically and horizontally to get the equations I need. So because this is mu r and mu r, what I'm going to do is say that if this is 18, this is 90, this is 18. Ah, crap. Let me look at this better. So I have this, and this is 18. This is a right angle. If I do that there, no. How do I want to do this? Parallel, perpendicular. No, that doesn't work. I want to do this. Um, what the hell, man? 90 minus theta. How do I resolve triangle? What the flip? Resolve forces? Yeah, this is 90. Okay. One sec. If this is 90, this is 90. This is 90 minus theta. This is theta, and therefore this is theta. My God, because this is the vertical. This is the vertical. This is theta. That's theta. Flipping hell. So we have this angle as theta. Okay, so basically what I've done, I is just trying to find this angle so I can resolve the force of R. That's my goal. I'm trying to resolve R vertically and horizontally. Flipping. So now I have this. This is R, the hypotenuse, and this is theta. Yes, it's in this direction. So R cos theta is the vertical upwards, and R sine theta is this way, where R is this. Now I can finally do this. Okay, F equals ma. Upwards positive. We have this Ra, plus R cos theta, Rc cos 18, is equal to the force down, 14G. I can work out Ra. Nice, because I know Rc. And then finally, I have F equals ma vertically. Um, Mu R is equal to R sine theta. Rc sine theta. And I know R, so mu is equal to Rc sine theta over Ra. Come. Come. Took way longer than it should, I think, in an exam. That would have been too long. Anything else? Go through hinges. Yeah, cool. It would be nice. Actually, the colors do tell you though. And the colors tell you if it's hot and cold. What's this? So when it's red, it's less. Green is more. So Perth has high pressure. Beijing has low pressure. Perth has high pressure. West Perth. That's Western Australia. Yeah, I'm not gonna remember these, man. Real talks. Beijing, China. Is China that far away from the equator? No. Where's China? Close to the equator? I think so. What the hell? Beijing has one of the lowest average temperatures, but it has one of the highest minimum pressures. Sorry, what the hell, man? Pun this crap. Cos of 90 minus theta is the same as sine theta. Yes, it is. Yes, it is better to sleep. So I reckon, but keep in mind the exam's 1:30. You can get enough sleep. No, 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 bro. EdXL have their own large data set, and they specifically said in the teachers, what do you call it? I don't know, meeting, that they will disadvantage students that do not are not familiar with the large data set will be at a disadvantage compared to people that do. So when they say disadvantage, do they mean a lot of marks? Do they mean they can't do questions, or do they mean that you won't be the questions will be harder? Don't know. I think they just mean the questions will be harder, or some things are just not accessible. Either one of them. Uh, what the flip? Uh, bun it, bun it, bun it, bun it. What's the next one? We should have a vague idea of the range of values. Hmm. Yo, I'm pretty sure there's a section of it in the book. The brown book. Is this the brown? Yeah, the brown book has a section on it in book one. So learn stuff from there at least. These lads are sending crazy stuff, man. I'm not gonna learn that color table. Damn. Southern Hemisphere, Beijing. I don't know why it would be colder for Beijing or higher pressure for Beijing. I don't know what makes pressure. Hopefully there's no pressure tomorrow. If there is, I'm screwed. Wah. Ooh.
Hello, and understand the large data set. The large data set includes weather information. Throw location information is collected only from May to October. It's important to remember this. The particular location. If you look
Half
at the
one, how
locations
far
in the
north?
UK, there are
Coastward.
which we'll put are about 30 degrees north of the equator and 30 degrees south of the 50 degrees north. Okay, let's take a look at temperature. Here are box plots of the winter in the southern hemisphere. So comparing Perth with Jacksonville, it's important to know that the data set has a number of gaps. These are marked NA, which means data is not. You need to also know
Data not
hectare.
available.
So if you were comparing, particularly in the UK, notice that there are a lot of outliers, particularly in the UK. So you'll see that it's getting more rain than everywhere else. But it's winter in Perth and it's summer in the other locations. As the
Price is
rainfall
0.05 or less.
than it was mile per hour, and you need times they ask
1.1
you
knot is
to
1.15
scale,
miles per hour.
which is a numerical scale
I don't know
with
beautiful Greek
discrete
scale.
values from 0 to 12, depending on the speed of the wind. This data set particularly has got a lot of gaps in.
Wow, man.
5 you
This is maths,
with
man. It's not
the
biology. You have to remember
east and
stuff.
so on.
Don't make it like
This
that, please.
again, our chart, a blue outline, 5, 6, 7, 8,
Octa is so
the
1/8
lower
of an
8.
octa. 1 octa is an eighth of the sky being covered in clouds.
So it's not distribution or light. So to give a summary, here we can say to it and it's also
Hectopascal, 100 newtons per meter squared. Nice.
relative humidity.
Sunshine is measured in 1/10 of an hour or 1/10 of a day. 1/10 of an hour. 1/10 of a day. Wow, flip it. I don't know.
Then that tends to relate to
Um. Yeah.
mist or fog.
Okay, when it's over 95% humidity, then that's when it's misty or foggy.
And then, so that's how far you can see.
Cool. That's useful, but I mean, I feel like that's too much information, don't you think? Way too much information. Oh, mechanics. Oh, nice. So that was the last stats question. To suck up everyone's time, prevent everyone from doing well in mechanics by just taking it up. That's what, 10 marks to 8, 14 marks. One question. Nice. Okay. So there was a vector question last year, so probably not this year then. There goes my probability. Yeah, two more vectors. Two vectors. Okay. This is nice. This is 3, 2, 5, 3. Nice. Okay. Any collision? Projectile motion. Ah, that's just a nice proof. Find the size of angle A. Well, you first find the final horizontal velocity, final vertical velocity, and do inverse tan of the final vertical velocity over the final horizontal velocity. Is that it? 15, 50 marks, 50 marks. Oh man, good luck everyone, man. Yeah, I think it's just have an idea. You guys go to school in Ilford, man, both of you. Yeah, I don't know, man. I feel like you guys are close by, but I'm not sure. You guys. Any other questions? Uh, oh, flip. Hinges, hinges. My bad. I keep on forgetting, man. Sorry, bro. I'll do it now. My answer here. What if what we worked out here? Sure that there was an average. Uh, independent candidate. Are you last year's Hamza? No, you're not. You're chilling right now, innit? Oh, actually, no. You're rate. Are you retaking? I'm not sure. If you're last year's Hamza, then I don't know why you're in my live stream, bro. You should be doing the live stream. uh, anyways, where was I? Question one stats. Turn my mic up. Oh, thank you for telling me so early, man. Is this too loud or is this loud enough or is this not loud enough? Let me know. Yeah, your question. Your question, the one with hinges. Second last is hinges. But there was a hinges question in the past paper. Should I do that one? I think that'll probably be better, innit? Get this out the way. Close this crap. Stats mechanics. Not this one. Not this one. This one is a hinge. I think it's a hinge. It's basically acting like a hinge, I think. Rough vertical wall with a reaction force is also basically a hinge. This is some long question. What the hell? It's still quiet, but it's better. So if it's quiet now, how quiet was it this entire time? Are you sure it's quiet for you? Because it's yellow here. So maybe you're just I don't know. I don't know, bro. It's fine now. Calm. Should I do? Yeah. Should I do the past paper or should I do your question? Which one do you think is better? Just got loud. Yeah. Cool. Yeah. Should I do your question or the past paper? Your one was a past paper. Do 2018. My guy. Cause it's more accurate. Bro, it's at Excel. Yeah. Memes at this point are infinite. You can just say yes, XL. Okay. Hope that can be read. Hope that's readable. Okay. Should I do different color? Huh. Okay, let's just stick to black. A plank AB of mass M, length to a plank is. They should say stuff like this when they mention the plank. I don't want to look on for it, flipping out. So here's mg, length to a rest. This is a um by rope tension T. Point C, small block of mass 3m on the point AP. So that's x. Okay, they put that. The plank is in equilibrium with in a vertical plane, which is perpendicular to the wall. Is alpha of tan alpha 3 over 4. Um, if you know 3 tan alpha is 3 over 4, then that's 3 over 4. Then this is 5. 3, 4, 5. Sine alpha is equal to 3 over 5. Cos alpha is equal to 4 over 5. Um, there's a reaction force R. There's a mu R here. A frictional force mu R because it's rough. The tension in the rope is 5 mg 3x plus a over 6a. Okay. Um. Yeah. Okay. Cool. So what we have is the first one. Let me add this one here as well. What's this? 3m. 3mg. So F equals ma for part B. For part A, F equals ma. Horizontally first. We get that reaction force is equal to T cos of alpha, which is R is equal to T 4 over 5. Cool. That's nice. Then we have F equals ma vertically, vertically. Um, T sine alpha plus mu T 4 over 5. Which part? How do I do that? I'll just go through what I said. So first, you know the triangle part. I just say tan alpha is 3 over 4, sine alpha is 3 over 5 because of the triangle. Now, what I'm looking at, I'm considering the fact that when something touches a surface, the surface has a reaction force perpendicular to itself. Like the surface perpendicular to the surface is a reaction force. So there's a reaction force acting through the rod plank. Because it's a rough wall, you can imagine, like, imagine this not in equilibrium. How would it fall? It's not going to fall from B. It's not going to fall from here. It's going to fall from where it's touching the wall. It's going to slip off here. So if it slips off here, you can imagine the friction is trying to resist it. So the friction is acting up. Next thing, looking at all the forces, I have this one acting in a direction, but everything else is perpendicular and parallel to these axes. So looking at it along the along the x-axis, I have a reaction force this way, and I have a component of this tension. So I can look at that component of tension and get this expression that R is 4t over 5. Now looking at F equals ma in the other direction, I get all the other forces combined now. So T sine alpha plus mr, sorry mu r, where R is this now, has to be equal to 4mg, 4mg, or is it 2mg of flipping? Oh, wait, hang on a second. This is wrong. This is wrong. There's a much better way to do this. Let me rub this out. My bad, my bad. I don't think this is wrong, but there's a much quicker way to do this, and that's moments. Why is it better? Because when you do moments about A, you don't have any of these forces. You just have these three forces, which is what you need. Mg and in terms of tension in terms of mg. My bad. Mg. moments about A this way positive, you have um, um, MGA plus um, 3 MGAX, 3 MGX, yeah, 3 MGX, and then that's where you get the 3x plus A from, is equal to 2AT um, cos alpha. Cos alpha? Yeah, cos alpha. Cos alpha, yes. So now I have mg 3x plus a is equal to 488t over 5. I think 2a times t times cos of alpha, where cos of alpha is 4 over 5. Yeah. Um, what the hell? Why do I have an 8? And this is a 6. Where's my mistake? MGA plus 3 MGX equals to 2A times T times cos of alpha. What the hell? Ah, yeah, yeah, obviously sign up. Yeah. What the hell, man? My bad, my bad. Thank you. Sign off. Okay, so you found me randomly from paper one. Yeah, that got a lot of exposure quickly as well. That makes sense. So this is 3 over 5. 3 over 5 time. Okay, yeah, that makes sense. Yeah, that's fine. So that's 6a over t 6at over 5. So this is 6a 5 mg over 3xa. Yeah, 3 5 mg times 3x plus a over 6a is equal to t, which is as required. The magnitude of the horizontal component of the force exerted on the plank at a by the wall is 2 mg. Oh, that's given to you. Oh, okay. So this is 2 mg. Do I now have to do F equals ma? No. At a by the wall is 2 mg. Find x in terms of a. Yeah, I can just find. Yeah. My bad. Yeah, do F equals ma. So 2 mg is equal to t cos alpha. So therefore 10 over 4, 10 mg over 4 is equal to t, which is equal to that. So now I can say 10 mg over 4 is equal to 5 mg 3x plus a over 6a. Mg's go, the this goes, this goes, this goes. So you get 1 is equal to, or in fact 3a is equal to 3x plus a. So you have 4a, oh sorry, 2a. 2a over 3 is equal to x, I think. You got it. Okay, cool. Cool. Next part. The force exerted on the plank at A by the wall acting in the direction of an angle beta with the horizontal. Find the value of tan beta. Oh, not bad. So I'm gonna get tan beta by first working out mu r. By first working out this component. I know that component is going to be equal to um. So all I'm saying is okay, not even mu r. Let's just call that a different force. Let's call that force Q, element PQRS. Let's call that S. Yeah. So now I'm gonna say S plus T sine alpha. S plus T sine alpha yeah, S plus T sine alpha is equal to 4mg, where T is this expression and X is this expression. So I can get S in terms of um I can get S in terms of mg and A. And because it's in terms of mg and A, what I can then do is say this triangle exists. This is S and this is 2mg, and alpha. Wait, do I have to find tan of beta in it? Beta. Beta. Tan of beta is just going to be S over 2mg. So yeah, that's mg should cancel out. Oh, but what about the A? Ah. Oh, wait, there is no A. What am I on about? There is no A. There is no A, but there is an A in terms of. Oh man, maybe I'm missing something. The force exerted on the plank at A by the wall acting direction. Maybe there's a better way to do it. Hmm. Plausibly, I could say that this is. No, that wouldn't work. Wait, hang on a second. Tension is not in terms of A. Tension is 10 mg over 4. What the hell? I was worried over nothing. Yeah. 10 mg over 4. So that's in terms of mg. So this will be in terms of mg. And yeah, so that's fine. I think this is it. Let me just quick time check. What question was this? 9? Yeah. Yeah, okay, cool. So they say y is the resultant and r sine beta and r cos beta is what I was working with. Where we were given r cos beta was 2mg. Yeah. And r sine beta is what I got from rearranging the other expression. So yeah, cool. Oh, there's another question. Flip, there's more to it. Yeah, but I think it was Muki or someone that said that they're watching because they won't revise. That's the only reason I'm live streaming, man. So I force myself to revise. Flipping, what's this? Adam, yeah, my guy. Sorry, bro. The rope will break if the tension in it exceeds 5 mg. Well, we know the tension is given by this expression. So the further away, the greater x, the greater P is away from the wall, the more the greater tension has to be. So basically, A has to be less than some value, which we can work out by saying 5 mg over 6a 3x plus A is has to be less than 5 mg. Cancel out. 3x plus A less than 6a. Um, so A has to be less greater than. Wait, what? A has to be greater than. A should be less than something. Uh, wait. Did I flip my inequality somewhere? No, I didn't. What the hell? A has to be greater than. The tension in the rope is 5 mg 3x plus A over 6a, where x is a constant. Oh no no no, that's fine. X is less than. Yeah yeah, my bad. A is a constant. X is the variable. Oof. Okay, so X is going to be less than 5a over 3. If X is greater than this value, then that means P is too close to B, therefore tension is too great and it will break. I don't know why it's 3 marks. I don't know. I think that's enough. Let's check. Oh, I don't think. Why is it equal to? Well, let me check. Oh, if it exceeds. So 5 mg is fine. My bad. I misread that. So 5 mg is fine. So therefore, it's a greater than or equal, less than or equal to. Block can't be more than away or just. Oh, so there's no reasoning whatsoever. That's 3 marks. What the hell? The comment must mention D from A, so you can get a mark even though you didn't get anything right. Cool, cool, cool. Calm. Yes, yes. Moments about A for this one, and here you can resolve vertically or do moments about B. I think I done resolve vertically first. Oh, that's the method I used. Cool, man. I think that'll be it for today then. That's I went through everything I wanted to go through. Year one stats is uh, year one stats, as my friend said, is most of stats basically. Just yeah. Oh yeah, last year. Let me look at that. Helen believes that the random variable C represents the cloud cover, discrete uniform distribution, probability distribution for C. Okay. Huh, what? What's the a discrete uniform distribution? So that's normal. But what's the mean? Uh, a probability distribution for C. Find a probability the cloud cover is less than 50%. Well, flipping. The only thing I'm thinking right now is doing mean of 50. So the probability is less than 50. It would just be a half. I don't know. Ellen used all the data from the last data set for her and then found that the proportion of days with cloud cover less than 50% was 0.1 of 315. Comment on the suitability of Helen's model in light of this information. Not very suitable because it's not uniformly distributed. Suggest an appropriate refinement to Helen's model. Uh, mm, Not too sure what I'd say for that. Just suggest an appropriate refinement. Don't model it as a discrete uniform distribution. Model it as a I don't know. Let's check. 1/9. Okay. Oh right, they measure in octaves. So 0 octaves, 1 octave, 2 octave, 3 octave, 4 octave. That's fine. What's this? Part B, PC of less than 4 point. Oh my days. So I need. So that's why you can catch people out. Because if you don't know octaves, you would have made a mistake like me. It's not discrete means it has to be like that. Okay. Use a non-uniform distribution. Cool. That would have caught me out, bro. Probably. Cool. I think I'm gonna have a much better time with mechanics and stats, honestly. And yeah, no idea. No idea. Look, if you have a look at the student room, apparently I think it's 15 and 17% people got less than 50, 30 marks. So that's crazy. Keeping that in mind, I don't know what the thing would be. Look at this. Look at this distribution. It's not even uniform. 3.66, 3.46, 4.29, and then flipping 16.34 right at the bottom. That's harsh. That's hard. 6,000 votes. If people aren't trolling, and this is the reality, that's unfortunate. Paper to mark scheme, basically, yeah. Yeah, this was such a nice way to do this edition. Trig identity. I ended up doing sum to product to sum rule, man. I made it so long, but either way, yeah, it was fine. I did not do a cobweb diagram. I just said this because that's the long-term behavior. Anyways, I'm not here to talk about paper two. Uh, did anyone have any questions? Cool, cool, cool. Do any eight of you have any questions? Um, hmm. Okay, this is basically the same thing though. 2mg, 30 is given to you. This is going to be mu r. This is r. Tension in the string T. You get that through doing. Um, is the mass uniform? Um, what was the uniform? Light and extensible. So you also have this mass here, mg. So tension moments about a positive direction clockwise. We have tension times 6a times sine of 30. is equal to um 3a mg plus 4a 2mg, and rearrange for t. Cancel out the a's, cancel out mg. No, there's no mg to cancel out. You find tension in terms of mg. Show that the horizontal component of force exerted by the force ball on the rod has magnitude that. You just say that t cos 30 is equal to r, and t cos 30 is that. Uh, was there anything else? Oh, if it says anything about mu r or find the coefficient of friction, you do F equals ma vertically with tension mu r and 3 mg to get mu r, and because you know you r, you can just find mu. Cool. So that's just a typical type of question now. Hmm. Oh, this is a lot of parts to a question, huh? Why are your questions so big? What the hell? Um, suitable distribution binomial. Work it out on a calculator, I guess. Tina takes a sample of 1,000 users of the drug. Oof. Now we have x be 1,000 0.02 h naught p is equal to 0.02 h1. Tina believes the company is wrong and that that more than 2% of users experience side effects. P greater than 0.02. Test statistic 28. Using a normal approximation, find the p-value for the hypothesis test. P-value, that's probably the critical value. So using a normal approximation, y modeled by the normal, 1,000 times 0.02, which is 20, I think. And then this is 20 times 0.98 square rooted squared. Yeah, squared. Um, p-value would be when I'll do like inverse normal with this two parameters and find the wait, what's the p-value? She finds that 28 individuals experience side effects. Using a normal approximation, find the p-value for the hypothesis test. Um, I'm not sure what it means. She finds that 28 individuals experience side effects. Using a normal, find the p-value for the hypothesis test. Flip. Hence, comment on Tina's claim at the 1% level of significance. Yo, Manve, bro, what does it mean? I'm not sure. No problem, man. I think you gotta convert the limits. What limits? From binomial to normal. To normal. Yeah, yeah. I done the NP thing. I done the normal distribution is equal to NP 1 minus Q or NPQ. Sorry, square root of NPQ. But what does it mean by p-value? Oh, safe. So we approximate the binomial distribution by that means we have a mean of that and a variance of that. So now x, yeah, I have that, and continue correction now p-value. What? The probability of x being greater than or equal to 27.5. Oh, I think. Oh, my bad, my bad. So it's saying what's the probability, the p-value of this for. Oh, so what's the probability for this test statistic? So the fact that. Oh, my bad, my bad. So because the fact that 28 individuals experienced this, given a probability of your normal approximation, what's that? What's the likelihood that this happened? So given this by a normal approximation, you can just do probability of x of y being greater than or equal to, no, not greater than or equal to, greater than, yeah, greater than or equal to 28.5, 27.5, because 28 needs to be included. 28 individuals did experience it, so to include 28 you have to do it from 27.5, using this binomial this approximation, and you can put that into your calculator. Hence, comment on Tina's claim at the 1% level of significance. At 1% level, whatever this probability is, if that is less than 0.001, 1%, wait, 10%, 100%, 10%, flipping hell, 100%, 10%, yeah, 0.01. If this is less than 0.01, then you can reject H naught. That means Tina's claim is correct. One limitation of hypothesis testing is there'll be like variances within the population. You're not always likely to get accurate representation. I don't know, something like that. Uh, Fluctuation due to sample size may impact the result. Okay, cool. The result is not significant because the probability was greater than 0.01, so Tina's claim is there's not enough evidence to suggest that. Cool, man. Cool, cool, cool. Yeah, yeah, quickly explain. So, wait, sample mean time questions. Which one? The one that Ishak sent? Uh, um, I rolled that expression as well. What the hell? Yeah, I think I did. E well, I don't, okay, where did I do it now? I need to find it. Uh, I think I done it in the stats page somewhere here, innit? The way the mechanics. This is mechanics. This is basically everything. Not this. Not this. Or was it this? Yeah. Yeah. It was this. Uh. Yeah. Okay. Sure. And so basically, what they done is they did not use the quick method. If you're here, I'm just gonna. So there's a quick method to do this by saying that whenever something is within one standard deviation. Yeah. Question 24. Whenever something is within two standard deviations, it's 95%. So we know the fact that plus minus 15 is, so 15 is basically two standard deviations. And because of that, it helps us do this question much quicker. Now, what they did is this idea that the mean, whatever the mean is, sorry, the x value minus the mean, the mean time minus their mean should be less than 15. And then what they done is they started saying that they started thinking about probabilities. So this area is 0.95 over 2. Okay, so consider the probability, consider this area and being 0.95 over 2. And then what they did is they found a z value, or conversely, this is 0.95 over 2. So this is going to be zero point 0.5, because this is 0.5. 0.5 minus 0.95 over 2, which is 0.25. And once you have this area, you can do the inverse normal, apply it to a standard normal, get the z value for this, and then express the z value in terms of x by multiplying, and by using z is equal to x minus the mean, which you know is mu, over the standard deviation, which you get from um, just the general expression square root of sigma squared over n, which is I think the method they're doing. Yeah, 0.95 um, mod of z being less than 15 root 9 or 40 is greater than 0.95, less than 0.25 by symmetry. So this is the argument I'm saying. Using the inverse normal function, they get the z value, and then the z value they change to, they equate to um, square root of sigma squared over n, I think, or something like that, and then they find root n. Yeah, 15 root n over 40 is just rearranging the expression. Whoa, what? Hang on a second. P of the mod of x minus mu less than 15 is equal to the p of mod of z being less than. I don't get that. What's this? Is equal to p of mod of z being less than 15 over that. Um, if you say so. Yeah, I'm not too sure what they're doing here, man. But I think this gives you the same answer. Let me check. Crap. 4 times 40 squared. It's a typo. What? Yeah, I get 28 though, so that's right, right? Okay. Sigma is 40. Yeah, yeah, yeah. Oh, right. Cool. What the heck? Yeah, that makes sense. Yeah. But still though, 15 over that is equal to the mod of z being less than that. Sure. Cool, man. Yeah, that's what I'm saying. I don't get that. I don't get why it's 15 over that. But the way I approached it, I didn't look at it as that. I looked at it in terms of area, and I know that this area is going to be equal to this z value. the probability of getting that z value or less than. So then I can express that z value or anything less than that in terms of mu and sigma and standard deviation and stuff. So yeah, man. I'm not sure what they done unless they done this. That looks about right. But wait, crap! It's 12 o'clock. I'm gonna go sleep soon. How you meant to do inverse normal with that calculator? You can do the inverse normal for a standard for standard normal distribution. For a standard normal distribution, you know the mean is 0 and standard deviation is 1, and then you make an equation with that in terms of this normal distribution. Yeah, yeah. That's why they get the inverse normal. Z is equal to. When they say Z, they mean the standard normal. No problem, bro. No problem. No problem. I wonder who these eight people are. One, I know two of them are at least Muki. One of them is no, one of them is Muki. One of them is Hamza probably. Other one's probably AJ. Oh, Mariam says, oh, hello man. Shuhan, that's four. Maybe this guy. Who's this? Who's the person that mentioned something? Maybe the yes, Sagar probably. That guy's probably one. Uh, hmm. Luminous. You're actually a goat. Sounded like a friend from my college. Mariam Sharif. Molly King the gamer. What are you saying, big man? You advertise yourself to 9 people, bro. Ah, yeah, sure. Yeah, sure, man. Send it through WhatsApp in it. Mariam. Where's Muji? High temperature is Jacksonville, apparently. What the flip? What the flip? Let's see if they confirm the answer. Or if she confirms the answer. Do I have the quant? Yeah, I do. Which question do you want me to do from the 2018 paper? Question 9. I think I done that. I think I just done that. Maybe not. Yeah, I done that. I done that at about uh I done that here. Yeah, question 9. So you probably can go rewind the stream a bit, and I done it. I made some mistakes, but I think my final version is the correct version. I mean, I skipped a few steps, but basically, yeah, you can rewind the stream and you find it. Here's question 9. Specimen paper question. If you want me to explain something, then let me know. I'll go back to that. That's fine by me. Yeah, yeah, no problem. I'll do question 3 from the specimen. Don't worry. Let me just go through my guys working out. 95%. Nice handwriting, bro. Sigma is 40. P of Z1 is 0.025. Z is that. Nice. Z2 is 0.975. Yeah. 1.959 x minus mu. I think, Sean, because you know that x1 is 15 less than the mean, instead of saying x1 minus mu, you can just say there. Oh yeah, sorry. Your mistake is not that. That's fine. Your mistake is the fact that the standard deviation is not 40. It's 40 over square root of n. The reason why it's for square root of n is because this is a sample mean. And when you do the sample mean, you change your variance and you change your standard deviation. It's in the book, and I also went through it in my stream when I began doing the distribution questions in the first place. But basically, that should be a 40 over square root n. Yeah, but that's right. That's nice. Um, One thing I would say though is, yeah, that's fine. Specimen paper question 3. Oh, this is your school, yeah? The Ilfracom. Oh, it's probably not your school. Then what from there you can rearrange for square root n. Nah, bro, because you know x1 is because you know x1 is 15 less than the mean, so it's the mean minus 15. So mean minus 15 minus the mean over 40 over square root n is equal to that z value. So then that you just get minus 15 is equal to minus that z value, minus 15 over that. So negate the minuses and then rearrange for square root of n. Yeah, you don't have the mean, but the mean cancels out. You can just say mean minus 15 minus the mean, because that's the formula for z value. The means cancel out. You don't really have to worry about mean. So which paper, bro? Oh, specimen. Hmm. Hmm. Oh, I done this one. I think I done this. Never mind. No, I have this. Okay, I have done this question. Um. Okay, I'm gonna give you a little tip, quick time. Maybe if you understand what this means, it's just a website with the specimen papers. Yeah, yeah. So this question is a double binomial expansion. You do one binomial expansion with a flower with n equals 40, p equals 0.36, and find the probability that um, p that sorry the number of white flowers. Wait, uh, more bulbs that can grow into plants with blue. Yeah, so find the probability that blue flowers is greater than 50. The reason why you want it to be greater than 50 is because that's the condition on the type of bag you want. Yeah, so one bag will have 40 bulbs. And what's the condition on a bag for it to be selected, you could say, is that the bag needs to have more than half of the flowers or more need to be, more than half of the flowers need to be blue flowers. So first, Find the probability that from 40 random bulbs, what's the probability that the blue ones are more than 20? Once you find that, make that your p for another binomial distribution. From that binomial distribution, n is 5 now, and your p is the one you calculated, and you want to find fewer than 2. So that's just p less than or equal to 1. And that's these 4 marks. Yeah? And then now for this 6 marker, you have, I think you just do a lower bound. Yeah, you can just put into your calculator, or not a calculator, you can do inverse normal for a standard normal distribution to find the z value for that like upper bound. Maybe if I have a pen, you find a z value for the upper bound. You want to find a z value such that this area is 0.0521. So inverse normal of do 1 minus that, do the inverse normal, you get a z value. And then with that z value, you can say, yeah, z is equal to x, no, 240. You know it's 240. So not x, 240. But you have to do a continuity correction to 239.5. No, sorry, 244.5, because more than 244. 244.5. 240.5. What the hell? What am I saying? 244.5. Minus the mean, which is NP, which not P, minus P being the probability you calculate in part A. No, P being this P. Yeah, yeah. P being 0.36 over N 0.36 1 minus 0.36 square rooted. You know the z value. You rearrange, and what you have is you have an n term, a square root n term. So you can imagine this is a 0.36n plus z square root 0.36 1 minus that, which is what, flipping 0.64 square root, and then this coefficient is square root of n minus 244.5 is equal to 0. So look at this. You have a quadratic with n. You have a quadratic in square root n, because this is the same as square root of n squared. So you can just imagine this is x squared and this is x. So when you solve this as a quadratic, you'll get square root of n is equal to the you can solve this quadratic and find x equal to something, but you know x is equal to square root of n. So square root of n is equal to that, and n is equal to that squared, and that would be your answer. Does that make sense? Cool, cool, cool. Glad to hear. Uh, what's your requirements for your university, Muki, man? 3A's. Good luck, bro. What's your other two subjects? Chem and physics, maybe? No. Maths? I don't know. Is it maths, chem, further maths? For him as well? Yeah. Oh, chem and physics, my guy. So you've done physics. I mean, finished physics is finished. I don't know OCR. Did you do OCR? Last thing, when you do when do you know when to use the V naught equation? What's that? V naught. V naught. One sec, I'll talk about physics in a bit. Wait, V naught equation. If you're talking about the vector equations, one sec. Yeah, type in the comment section what you mean by V naught equation. OCR paper 3, bro. I'm not gonna lie, I don't even remember the papers like that anymore, man. I remember 2018 papers more, man. I remember the flipping. I didn't even calculate my marks properly, so I'm not even sure what my marks are. Mm. Imagine I made another paper 2. Um, sorry, I meant R is equal to R naught plus VT. Yes, okay, sure. So you know how you know this. So imagine you're an object starting from here with a velocity v in this direction. Let's say in this direction. Your displacement from this point at any given time t. Let's say you move like that. Oh, you're not gonna move like that. You're gonna move like this. You move like this. Ah, flip sake. You move. Oh, now I have to rub it out. Shapes, lines. Come on. You move like that. In a given time t, your position, this will be given as r. Now, because it's relative to here, imagine you can imagine at time zero, your like if you just sub in t equals zero, um, vt. If you sub in v equals t equals zero, you get v times zero, which is zero, which makes sense. Your initial displacement is zero. But now when you go vectors and you have an origin and you have an initial position vector for your initial position, and then you have a velocity as well. When you sub in t equals zero, r naught is just your initial displacement from the origin. So that makes everything with respect to the origin. So your displacement from the origin at here is given as r naught plus vt, where v is a vector and r is your displacement from the origin. This is assuming you have a displacement from the origin. You can get r naught by just integrating. So if you have like one sec. So you know acceleration is equal to zero. No, sorry, my bad. Imagine they say given velocity is 4, find an equation for the okay, they'll say something like the particle starts at 1 2. Oh man. The part They'll say something like this: initial position of the particle 1 2, velocity 4. Find the displacement equation. Well, you can just say that displacement is equal to the integral of velocity, which is equal to the integral of 4, which is equal to 4t plus c. When t equals 0, 1 2 is equal to c. Therefore, r is equal to 1 2, not this, plus vt, where v is a vector. Does that make sense? Yeah, just these two sentences made up for everything I said. Good. That's good to hear. Mubarakallah fi. 2 hours 40 minutes, man. Is this my longest stream? Don't know. I wonder how many people actually check out the rest of what my YouTube has to offer. I mean, it's nothing much to be honest. It's just some more questions. But yeah, if I went through paper 2 and I went through paper 3 as well, as in mechanics and stats tomorrow, Fortnite. Yeah, I mean, I used to be decent back in the days, man. But what can I say? Not anymore. Hey, how are you guys using the stream then? Are you like, do you have it on the side and you're doing your own questions, and when I go through something interesting, you like glance and watch? Is that what's how you're making the most of it? That's what you're doing. Yeah, that makes sense. I wouldn't expect anyone to just watch me straight for 3 hours or 2 hours. It's better to do your own questions, go through your own revision, and then if I go through a question you want, yeah, doing a paper at the same time, yeah. But then I hope I'm not too distracting then. I don't want to stop you from working on the exam condition. Cool, man. As long as you find it useful, that's cool. That's fine by me. Uh, your streams look very helpful. Good to hear. That's good to hear. I think it's mostly because you like if you answer a question, you ask a question, you can get an answer as well. Um, Obviously it depends on who you have available to ask, but yeah. Originally, I thought it would just be, people from my school, some of my friends. I didn't expect it would be people from other schools as well. But I think that's only because of my first paper video that it got recognition. As you said, you came from paper one. But yeah, you sure? Do you want to play some Osu? What course am I going to? I've applied to Cambridge and Warwick. Um, I mean, as in my firm is Cambridge, my insurance is Warwick, and I've applied to do maths and physics. So yeah, it's mostly maths to be honest. Warwick is half maths, half physics, but Cambridge is first year 75% maths, 25% physics, and then the rest of the 3 years is basically full maths. Thanks, man. It's not as top quality as or exam solutions or anything. Safe, bro, safe. Yeah, Cambridge don't make it easy setting additional exams just for maths. And there's no one to do petitions for that. Maximum people that will sign it will be like for 10 people flipping. Oh god. Cool, then I'm probably gonna end the stream then. I don't think anyone has questions. Everyone's chilling. Some people are blanking. That's upsetting. Oh my god. What the flip? Right. What joker? Cool then. Starring brothers. I'm gonna stream.